Today's tutorial is on monitoring line current of a three-phase transformer. So in here we have the load and the current sensors all connected in series. And this current sensor is for um, detecting the earth current flowing from the three-phase transformer. As you can see, the three-phase transformer has three lines. The ultrasonic sensor for detecting distance, the LM35 for temperature, and the GSM module with a virtual terminal that will help us send message virtually when we simulate the project. So let's simulate this project and see what happens. Okay, as you can see, that's the virtual terminal at your left side, and this is the LCD displaying line currents, the temperature level, and earth current. So these are all what we'll be monitoring in this tutorial. Let's get started. Open Proteus Design and create a new project. Let's go on by placing the components of this project. Click on P. Now search for the component you want to place. Let's go on by searching the Arduino. For the Arduino, make sure you select the latest version of it, which is the R3 version 1.3. The Uno R3 version doesn't seem to work in the simulation. Without wasting time, I think I'll go fast here. I want you to take note of this. When you select DC from generators, make sure to select 5 volts to all modules and sensors, or wherever you see VCC or VSS. Done. Now double click on it and key in the voltage you want. For here we'll use 50 Hz for now. I'll go on by explaining why I use the 440 volts over here. So click OK and do the same thing for the other ones. Before I explain the three-phase ideal transformer, I like to give a quick explanation on turns ratio. So you'll be given this basic example where we have turns ratio is equal to 3:1. Mind you, we are stepping down our voltage. So the secondary voltage divided by the primary voltage, which is giving us let's say we have been given 240 volts as the primary voltage, but we don't have secondary voltage. So in here, basically you are just going to make the secondary voltage the subject by dividing primary voltage over 3. So when you divide primary voltage over 3, you are going to get 80 volts. So in our simulation, since our primary voltage is 440, it's just basic. We are just going to divide 440 by 2, which will be giving us the 220 volts for the simulation. Okay, now let's head back to the simulation. In here, as you can see, 2. So 440 divided by 2, I'm getting 220 as a secondary voltage of the ideal transformer. Okay, for the lamp or the load, I'll be using 120 volt. I like to say this. Basically, this simulation is just to give you a fair idea of what or how the project is to be built. If you have this understanding, you could use any value of your choice. Since this simulation they're all virtual, it's just to give you an idea. So let's go with the ultrasonic sensor. We have this potentiometer to vary as its distance. We have the GSM module working together with a virtual terminal for values to be displayed on the left side of the design. The Arduino, the LCD for displaying the conditions of the transformer. Straight to the current sensor, which is actually going to sense current from the ground or the earth of the transformer. The LM35 for sensing temperature. Then this current sensor in series to the load or line for detecting line current. Let's run the simulation. 3 line currents, earth current, temperature, oil level. All these currents have threshold right from the current sensor. The ACS 712 current sensor of 20 ampere. So when current is beyond that, it must get the ACS 712 of 20 ampere current sensor damaged. That's why line currents are all being monitored below 20 ampere. Now let's try to simulate temperature by manipulating these values, as well as simulating the ultrasonic to get values. Okay, by increasing temperature, it goes beyond its threshold, then it sends high transformer temperature, as you can see on the left side. The virtual terminal, where it acts as a medium or a device with the help of the GSM module by sending a message to that device that there's high transformer temperature. Okay, so we'll be varying distance on the potentiometer for it to display on the LCD. So wait a second. Wait a second. There it goes. Oil tank full. For the line current, when the line is overloaded and there's a drop of current or a low current, we'll be receiving a message that line is overloaded. There you go. Line 1 overloaded, line 2 overloaded, line 3 overloaded. Basically, I've programmed it that when it goes below its threshold, there should be a message sent. Please watch my previous video to know how to copy the code from the Arduino to the Proteus. That's all. Thank you for watching, and please subscribe.